up in the world of robotics and AI. It's an open source platform that's not just a physics engine, but a complete simulation ecosystem. This tool is about speed, simplicity, and power, built to solve problems that have held back robotics research for years. Designing realistic simulations has always been a challenge. Expensive hardware, endless manual processes, and complex software are the norm. Genesis changes the game, making high-speed, high-quality simulation accessible to anyone with a decent computer and some Python skills. Now, I'm about to show you something that will absolutely blow your mind. You've probably never seen anything like this before. Watch closely, and then I'll break it all down for you and explain why this is All right, now, what sets Genesis apart is how fast and efficient it is. It runs simulations up to 430,000 times faster than real life, clocking 43 million frames per second on an RTX 4090. Most platforms don't come anywhere near that. Genesis is 10 to 80 times faster than widely used tools like Isaac Gym and Mujoko MJX. This means robots can train in hours instead of decades. With this kind of speed, training neural networks for complex tasks like picking up objects, walking, or manipulating tools becomes dramatically faster. Genesis makes it possible to achieve the virtual equivalent of decades of training experience in just 1 hour. At the core of Genesis is a robust physics engine designed to handle a wide range of materials and phenomena. It integrates state-of-the-art solvers for rigid bodies, fluids, and even soft bodies into one unified framework. The entire platform is built natively in Python, from the front-end interface to the back-end physics engine. This makes it more accessible and user-friendly than platforms relying on C++ or CUDA for their core calculations. Compatibility isn't an issue either. Genesis works across Linux, macOS, and Windows, and it supports CPUs, NVIDIA, AMD, and Apple Metal backends. Genesis doesn't stop at speed and compatibility. Its generative capabilities are a major leap forward. The platform can create entire 3D worlds based on natural language prompts. Typing a simple description generates interactive scenes, task proposals, character movements, and more. This reduces the need for manual asset creation, which is usually a tedious and time-consuming process. The automation Genesis provides frees up researchers and developers to focus on innovation instead of spending hours on repetitive tasks. The visuals are just as impressive as the speed and functionality. Genesis features a photorealistic rendering system that uses advanced ray tracing. This means simulations don't just perform well, they look incredible. High-quality visuals are critical for presentations, research, and collaboration, and Genesis delivers on that front. The rendering capabilities make it easier to demonstrate of simulation, but also incorporate motion over time. These environments are created using vision language models, allowing users to describe scenarios in natural language, which Genesis then brings to life. Whether it's generating camera movements, realistic object behaviors, or physically accurate animations, Genesis simplifies the process to an incredible degree. The flexibility here isn't just about robotics. The same tools could be used to create assets for video games, animations, or even AI-generated videos. Genesis also excels in scalability. It can run up to 100,000 copies of a simulation at the same time. This parallelized simulation capability is invaluable for training neural networks. When you can test billions of scenarios in virtual space, you end up with AI models that are far more likely to perform well in the real world. One of the researchers behind Genesis described it as controlling thousands of robots performing millions of skills in billions of simulations. That's the level of scale we're talking about here. What makes Genesis especially exciting is how easy it is to use. Installation is straightforward with a simple PyPI command, and the API is designed to be intuitive. Even developers who are new to robotic simulation can get up and running quickly. The platform is fully open source, meaning anyone can contribute to its development or customize it for their needs. The team behind Genesis encourages collaboration and feedback through GitHub, where users can suggest features, report bugs, and share ideas. The roadmap for Genesis includes some ambitious goals. Differentiable solvers for rigid body physics and tactile sensors are in development, along with features like tiled rendering, faster JIT kernel compilation, and large-scale environment simulations. The team is also working on a comprehensive generative framework that will expand the platform's capabilities even further. This framework aims to include features like facial animation, character motion, and interactive scenes. These advancements will make Genesis even more versatile, allowing users to tackle increasingly complex problems. The platform supports a wide range of robotic platforms, from arms and legged robots to drones and soft robots. It's compatible with multiple file formats, including MJCF, URDF, OBJ, and GLB, making it adaptable to various projects. The built-in ray tracing ensures that every simulation looks as good as it performs, which is crucial for both research and presentation purposes. Genesis has already achieved some impressive milestones. It can deliver physics simulations at speeds up to 40 to 3 million FPS on high-end hardware, train real-world transferable robot locomotion policies in just 20 to 6 seconds, and simulate environments 10 to 80 times faster than existing platforms. The combination of speed, accuracy, and ease of use is unmatched, and it's opening up opportunities for smaller teams and independent researchers to compete in a field traditionally dominated by well-funded institutions. The platform's community-driven development model ensures it will continue to grow and evolve. Contributions from researchers, developers, and enthusiasts are welcomed, whether it's through pull requests for new features, bug reports, or even small suggestions to improve the API. The goal is to create a fully transparent and user-friendly ecosystem that pushes the boundaries of what's possible in robotics and AI. Genesis is more than just a tool for robotics research. It's a platform that democratizes access to high-quality simulations, making it possible for anyone with a passion for robotics to bring their ideas to life. By lowering the barriers to entry, it's paving the way for a new wave of innovation in the field. Researchers can now focus on solving complex problems instead of getting bogged down by technical limitations. With Genesis, the possibilities are endless. It's not just about building better robots, it's about